We have an agenda. This is today's agenda, so I'm going to pass it to Rishika, the speaker, to talk about the section.
All right, so the agenda for today, we're going to start out with a recap of session 4, and then we're going to go into the meat of today's session, which is programming logic. So it's kind of consists of just going over the elements of flow control and then actually going into the different flow control statements that we have. This includes if, else, and elif statements, along with the while loop and for loop. Then we'll get into some live coding on Google Colab, as you've done in previous sessions. And then we'll do just a quick wrap up, a recap of today's session, and then what to look forward to for next session. All right. So let me just make sure.
Sorry, I stopped the screen share. Sorry, I didn't realize it.
No, it's okay. It's okay. All right, let me just make sure I'm sharing the right thing here. All right. Can everyone see that okay?
Yep.
Okay. All right, I'm just going to. All right, so as I said, this is our agenda for today. So for the session 4 recap, you can please visit this link. This is our Women Who Code YouTube account for when the recording is available. That should be sometime soon. And then you can always review the slides and code at this link. This is a link that we always refer to, where we have all of the resources for session 1 through 4, as well as today's material. So we've gone over Python data types in the past 2 sessions. We kind of had a part 1 and a part 2. So in part 2 specifically, we brought up Booleans, and that's kind of going to be a very important data type for today when we're talking about programming logic and how to sort of bring logical statements into Python. So just as a reminder, we have Boolean values and operators. So the 2 different values that you can have the Boolean data type is either true or false. So it's kind of this binary option that you have. And then we also have some operators to go along with that. So the operators, we kind of have the 2 columns here. So here are all the operators. We have a double equal sign, just to mean equal to. Then we have an exclamation point, and then the equal sign that means not equal to. Then we have the less than sign, that's less than, greater than is the greater than sign is greater than. And then we have less than or equal to and greater than or equal to. So these are going to be important for when we're talking about programming logic and flow control. So the first section, we're going to go over the different elements of flow control, and this includes conditions and then the actual blocks of code. So the conditions, here's kind of a nice image showing you kind of what I mean by the condition and the statement. So if you were to think back to the Boolean data types, where we have either true or false, those are kind of these Boolean expressions. And that kind of translates to a condition. And a condition is just basically a more specific name in the context of flow control statements. And so these conditions always evaluate down to either to a Boolean value of either true or false. And depending on whether the condition is true or false, you kind of decide what to do based on the result of that condition. And almost every flow control statement out there uses a condition. So if you look here, you have a condition, and then if it were to be true, you sort of evaluate whatever statement is in here, and then you sort of continue on. But if it's false, that means you never actually visit the statement here and you just keep going forward. So and I sort of think of it as kind of like a flow chart where you have different options, 1 or 2, true or false, and you kind of take different paths depending on what the condition evaluates to. And then now for the blocks of code. This is actually the lines of Python code that are grouped together in blocks. So you've seen a lot of Python code in previous sessions. You can kind of refer to this as a code block or a block of code. And so the block begins and ends from the indentation. So as you can see here, we have separate blocks like this. So from going from block 1 to block 2, you're sort of going 1 indent in. So that's a separate code block. And then you go 1 indent further, and that's a 3rd code block. But then you can go back out 1 indent to the left, and now you're back into the 2nd block. So it's kind of continuing block 2. And then you can go further out back to block 1, and it's sort of continuing block 1. So indentation is really important. Just in general, syntax is very important for programming, but especially when it comes to indentation, because that basically means that you're visiting a different block of code. And things are going to evaluate much differently if they're in the same block versus in a different block. And you kind of have these three rules for blocks. So it begins when the indentation increases. So as you saw from block 1 to block 2, your indentation is increasing sort of by one step. So a new block is beginning. It can contain other blocks. So you can actually have sort of blocks sort of nested within a single code block. And then a block ends when the indentation decreases to 0 or to a containing block's indentation. So as you can see here with block 2, it ends when you sort of decrease the indentation. So you're going from block 3 back to block 2. And so now you're sort of closing out that block. And so it ends either when the indentation decreases. So when you're going from block 3 back to block 2, or when you're going all the way back to 0, essentially this first initial stage of block 1. And here's kind of an example of what actual code would look like. So as you can see here, we have, I'm not going to explain too much about the code, but I just want to sort of show you that what is a block of commented lines looks like. So as you can see here with these quotations, that's basically defining this block that we have, and then it's sort of nested inside of here. And we're going to be seeing a lot of blocks of code when we go to the live coding with Google Colab, and I'll make sure to sort of reiterate this when we get there. So this is a little diagram showing the different, how we have conditions, how we have evaluation of the conditions, and then how are these different blocks of code. So if you were to see here, everything that's circled in orange is a condition, and then the condition being evaluated is either yes or no, or that Boolean value of true or false. So as you start from here and then you say is raining. So that's the condition. And then when you evaluate it, it can either have yes or no. So let's say we took the yes path. Then we meet another condition of have umbrella, and then you go to no or yes. So let's just follow the no here. That's again another evaluation. And then let's see, okay, wait a while. So this one, as you can see, doesn't necessarily evaluate to like a yes or a no, but it sort of just goes, keeps on going down to is raining. And then from here, you can go back up here to wait a while, because if it evaluates to yes, and if it evaluates to no, we go all the way to the left here to go outside, and then you can end. And an important thing is that everything that's sort of in this diamond shape is a branching point. And that branching point is essentially where you have those true or false, those different ways that the condition can be evaluated. And depending on that, you actually take a different path through this entire flow chart. So hopefully this helps to sort of clarify kind of when you're thinking about flow control, it helps think of it as a flow chart, or where you have different conditions, and depending on the evaluation of the condition, you're going to take a different path in that flow chart, and then you're essentially going to have a different result at the end. All right. So now that we went over the elements of flow control, I'm going to actually get into the different flow control statements that we have. So we have conditions and we have loops. So under conditions, we have if, else, and elif. And then for loops, we have a while loop and a for loop. So an if statement is actually the most common type of flow control statements. I'm not sure if you guys have heard this before, but it's a really common thing to say kind of an if else block or an if statement, something like that. But basically, this is a clause that will execute if the condition is true and is then going to be skipped if it is false. So to put it into plain English, if this condition is true, execute the code in the clause. So going back to here, you can sort of see that if it's yes, then we go to have umbrella. So you can sort of see that the is raining could sort of be transformed into an if statement. And right now, this is all very in plain English, but that's just one way to think of it, that if it evaluates to true, then we're going to, if this condition evaluates to true, then we're going to then follow along this path and move on to the next sort of code block that you have. And every if statement consists of the following. So it has the if keyword, so that that's really important. And you have to make sure that it's all in lowercase. And then you have the actual conditions. And this is a condition that evaluates to true or false. So as you saw in the flow chart, this could be like is raining, or is hot, or is cold, something like that. And then you have a colon, and this colon is really important. Syntax is very important. So you're basically going to have if condition colon, and then inside that, you're actually going to have the if clause itself. So if that if the if statement's condition evaluates to true, then you actually will visit the code that's in that clause and then execute the code that is in there. So to sort of show you kind of what that code looks like. So this is the if keyword that I was talking about. This is the condition itself. So name is equal to Rishika. So this is our Boolean operator that I referred to. And this is basically saying if the name is equal to Rishika, which is in this quotation, so it's essentially a string, if you remember from our data type session. And then inside here is the clause itself. So if it's true that name is equal to Rishika, then we're going to execute the code that is right here. So then if name is equal to Rishika, we're then going to print out, hi, Rishika. And here's kind of going back to that flow chart to show you how this looks like. So we start out here, and then this is sort of our condition that we're basically evaluating. And if it's true, then we print out hi Rishika. If it's false, then we just end and there's nothing to do there. And that's kind of how an if statement works. If it's true, then you're actually going to carry out the code that is in there. But if it's not true, then you basically just skip over it and nothing happens. But from there, we can sort of build onto an if statement with an else statement. And this is sort of as it optionally follows an if statement. And this is executed only when the if statement's condition is actually false. So if we were to have that condition be executed for the if statement, if that were to execute to true, then you execute the clause that is in that if statement. If that if statement executes to false, then we execute whatever is in this else statement. And so just to put it into plain English, if this condition is true, execute this code, or else execute that code. So that's kind of, hopefully that helps to sort of break it down a little bit. And in this case, you actually have, you don't really have a condition because, and it'll help to sort of put this together with the if statement to show you why we don't really have a condition associated with the else statement. So all you have is the else keyword, the colon, and then you have the else clause. So just to show you, we're putting together this sort of building upon the example that we already have. So this is our if statement of name is equal to Rishika. And then we just have the else. So we have the else keyword and a colon, but there's nothing in front of that else keyword. For the if statement, we actually had some sort of condition that we had to either execute to true or false. But in this case, this is basically saying that if this if statement is false, we just jump right to the else statement and we're going to evaluate no matter what, whatever is inside here. So visiting this flow chart again, if this evaluates to true, we print out hi Rishika, and basically once that condition is met, we just get straight to the end. We just completely skip over this else statement. But if this name equals Rishika is false, then we visit the this clause here that says print hello stranger, and then we end. And let me just make sure there's any. All right, I don't see any questions, but feel free to drop any questions that you have in the Q&A box, please. And then before we jump over to the live coding, we'll make sure to revisit that. All right, and then the last one that we have for our different flow control statements is our elif statement. So you want one of many possible clauses to execute. So elif is actually, if you break it down, it basically means else if. And it always follows an if or another elif. And this condition is checked if all previous conditions are false. And it's kind of hard to describe all this just like with English, so it does help to look at the code itself. But just to sort of make things clear, an elif statement consists of the following. So again, we have that elif keyword. Then we do have a condition here because it's kind of similar to an if statement. It's not like an else statement where there's no condition. For an elif statement, you do actually have an associated condition that then evaluates to either true or false. And then we end that first line with a colon, and then we have the elif clause. So let's sort of build upon our running example. So if name is equals Rishika, then print out hi Rishika. Same thing goes here. If we evaluate to true, it prints it out and we get to the end. But now we've added elif age less than 20. So as you can see, we're using that Boolean operator of that less than. And here what we're saying is that If this name equals Rishika evaluates to false, then we visit another condition of age is less than 20. And if age is less than 20 and that's true, then we're saying that you are not Rishika, kiddo. So that's basically saying, Rishika is not, that whatever person that you're referring to is less than 20. But then if age is less than 20 evaluates to false, then you get to the end. So essentially, you're not evaluating any of these. And what typically happens is that if you have a pretty comprehensive flow control, series of statements, you'll typically have an if statement, then you'll have maybe a couple elif statements, and then you'll end it with an else at the end. And that is really useful for different, like maybe if you have different cases that you want to check. So if you're trying to figure out if a number is of a certain value, you can check, oh, is it less than 10, but is it greater than 5, or is it equal to 7? So you can basically check through different things, and this is all done using Boolean operators. And so that's why the Boolean data type is so important when it comes to flow control. All right, so that's everything for if, elif, and else statements. And we're going to revisit all of this when we get to the live coding. But for right now, I'm going to start talking about loops. So the first loop we have is the while loop. So this is basically a loop that's executing code over and over again. And it's basically keeps executing as long as that condition is equal to true. And a while loop consists of the following. So again, we have that keyword. So here we have the while keyword. Again, as a reminder, all of these keywords are completely in lowercase. If they're not in all lowercase, then it's not going to evaluate properly, and you will get an error. Then you have the condition that follows the keyword. And again, this condition evaluates true or false. Then you have a colon for that first line. And then you have the clause that's sort of right below that. And so it's similar to an if statement in a lot of ways, but it's slightly different in how each of them behave. So after an if statement, the execution continues on. So as you saw, if the if statement evaluates to true, then you sort of just end, and then you're done with running that piece of code. If the if statement evaluates to false, then maybe you end the code, or you visit another elif statement, or you visit an else statement. However, for a while loop, after the while loop, you actually jump back to the start. So if the while loop is executing true, so whatever condition is associated with the loop, as long as it's true, you basically keep going on and on and on and on. And this does cause an issue of where you can get into an infinite loop, and that's a terrible nightmare. It's something that I think every programmer has come across. So that's why while loops are very tricky, because you have to keep in mind that as long as that condition is true, you're going to keep running that piece of code over and over and over again. So here's sort of a comparison between the if statement and the while loop. So here we have, say, spam equals 0. So this is basically declaring a variable that's called spam, and it's set to a value of equal to 0. So we kind of have that same thing going on for both of these. And then here we have our if statement. So if spam is less than 5, and then here we have while spam less than 5. So as you can see here, the only difference is the keyword. So here we have an if statement, and here we have a while loop. And then these are the different clauses we have inside. So the first one is print hello world, and then print hello world, spam equals spam plus 1, and the same thing over here. So even though everything is the same about these, but the only difference is that this is an if statement and this is a while loop, the output is actually that hello world is then printed one time only for the if statement. But for the while loop, it's actually printed out 5 times. Because as you can see, as long as this condition of spam being less than 5, as long as that condition is being evaluated to true, you basically will evaluate spam equals spam plus 1 and return back to the beginning of this again and say, while spam is less than 5, print this and that. And it keeps going on and on and on. And the reason why it's printed out 5 times is because right now we're starting out with the value of spam being completely 0, right? But every time we run this code, we're basically adding a value of 1 to spam. So we run through it once, then spam equals 1. And we run through it a second time, spam equals 2. And so as long as spam is less than 5, we're going to continue printing out hello world. But if we print it out once, we have 1, 2, 3, 4, 5. So as long as that spam value is less than 5, we're going to keep printing out hello world. And that's why in this case, hello world is printed out 5 times. But now let's switch over to the if statement. So here we're only checking it once, right? We're not actually returning back to the if statement in any way. We're just going to execute whatever is inside this clause and then continue on. So if spam is less than 5, we print out hello world. And then spam is then increased by a value of 1. So spam then equals 1. We print out hello world just one time, and that's it. So I hope that sort of helps to sort of show this distinction between an if statement and a while loop. So they are very similar, but they are different in how they behave. And just with changing one keyword, you can have a very different output in your code. All right, so now I have a quick poll. And to answer this poll, you can very simply just put in either A or B into the chat. And so what my question is, I want to ask which between A and B, which one is referring to a while loop? So again, between A or B, which one is referring to a while loop? And so in the chat, just drop in your answer, A or B, and we'll just give it a few moments for people to sort of put that in the chat. All right, I see a bunch of Bs. Okay. All right, so yeah, B is correct. Good job, guys. And the reason is because, as you can see in this flow chart, referring back to that same code that we had here with if spam less than 5 or while spam less than 5, as you can see here, we basically evaluate this once and then just go straight to the end. So that's definitely an if statement. And then for the option B here, we evaluate spam as less than 5 once, print hello world, change the value of spam, and return back to that same condition. And we keep going until spam is the condition spam is less than 5. Until that becomes false, we keep going in that loop. So great job, everyone. You all got that right. I'm glad that everyone is able to sort of understand this distinction. It is one of the very fundamental things, not just for Python, but just for programming in general. So you should all be very proud of yourselves. So if I could give you an actual high five, I would, but here's a virtual high five. All right, yeah, so the answer is B. And so here are just some additional statements for while loops. I'm not going to go too into depth with these because they're kind of a little bit more advanced, but I just wanted to introduce the concepts to you. We do have this in the code that was provided to you. However, we have, for these two things with the break statement and the continue statement, we already have the code sort of filled in for you, since we won't actually be coding that live together. But just to get into it, so a break statement is used directly inside the loop, and this helps to immediately exit the while loops clause. And for this, you only need the break keyword. So this statement is really useful when, say, you're getting stuck in an infinite loop with a while loop and you want to just immediately exit it. You can simply add in this break keyword, and that's it. You don't have to put anything else with it, just on that, and just in that same clause at the end of the clause on the last line, you can put in this break keyword, and then when the code is running through it, it'll see that keyword and immediately exit the clause, the while loop clause, and whatever infinite loop or anything that you're stuck in that, you can immediately leave that. So it's definitely very useful. And then you have the continue statement. So this is, again, also used directly inside the loop, and this helps you immediately jump back to the start of the loop and then reevaluate the condition of the loop. So this is kind of like the opposite of the break statement. The break statement is kind of like, okay, I want to get out of here, let's leave this loop. But a continue statement is you want to sort of jump back to the start of the loop and keep going and keep reevaluating the condition. So they're kind of opposites to each other. And then, yeah, so I see a question about when you would give an example or give an example of when you would use a break statement. So break statements are used when you want to immediately sort of leave the while loop. And so typically they're used if, say you want a while loop to run only a certain number of times, or if you're testing out your code and like something happens and you get stuck in an infinite loop, or you want to avoid getting stuck in an infinite loop and you're sort of thinking ahead, then you want to just include that break keyword in the clause directly. And then when the code is being executed, it'll immediately leave that loop, and then you won't get stuck in sort of that infinite loop situation. All right, so the last component for today is the for loop. And so a for loop is when you want to execute code for a specific number of times. And just to compare, while loops actually keep looping. So this is very different because here you actually specify the number of times that you want to execute that piece of code. And a for loop consists of the following. So you have the for keyword, again, all in lowercase. Then you have a variable name. Then you have the in keyword. And then from here, you kind of have two options. So here you can actually call the range method, so range parentheses. And this is inside that range method, you can put up to 3 integers that are passed into it. So basically inside that method, you could have 3 different values that it can sort of take in. Or you put in any sort of iterable that has already been declared. And iterable is actually something that we have already gone over. That's basically like a list or a string or a dictionary or a tuple, any of those. So as long as you already have something like that declared, then you can actually visit that that data type that's already been declared, and then sort of execute this for loop on it. And then you have a colon to sort of close out that first line. And then inside that, you actually have the for clause. So here's an example of a for loop. So say I have print my name is, and then this is where the for loop actually starts. So you say for I in range of 5. So basically, this is your for keyword. Then you basically have I, and this I can basically be replaced with any other sort of lowercase letter. Typically I is used. That's just kind of the standard for programming. And then you say in, so that's kind of another keyword, is the in keyword. And then here I'm showing you the first way where you can actually call the range method. And it basically takes in the value of 5. So, and then inside here, this is our actual clause, and we're basically saying print Rishika 5 times. And this is just some sort of this is just some extra formatting. But what I want to make sure you guys understand is that if we start here, then we go to print my name is. So that's basically before we even get into the for loop. And then for I in range of 5, this is where our for loop starts. And basically, we are specifying it to basically loop through 5 times because we've said a range of 5. So now we're able to print Rishika 5 times. And then once this loop has executed a total of 5 times, it'll recognize that it's done it already 5 times, and then it's going to stop looping, and then we get to the end, and that's it. So it's kind of very different from a while loop because a while loop will keep going until it's false. But a for loop in advance, when you're defining it, you're basically telling it how many times you want it to go through whatever piece of code that you want to be executed. And then just to show you kind of an equivalent while loop to this. So again, we have this print my name is. This is sort of outside of the loop. And then I don't want to get too much into the details of kind of the code itself, but I just kind of want to show you how we can have the same condition of printing Rishika out 5 times, how we can do it without a for loop. And here what we're doing is that our while loop is basically saying while I is less than 5, then we print it out 5 times. And if you remember, we kind of had the same thing with the spam equals spam plus 1. Here we have I equals I plus 1. So basically every time it goes through the loop, it adds a value of 1. And we're starting out with a value of 0 for I. So basically it goes through once, then 0 turns into 1. We evaluate another time, then 1 turns into 2. And basically it does it 5 times because you're basically going to stop when I is no longer less than 5. And it basically until I is less than 5, that means it actually loops 5 times. So that's how you're able to basically predefine this while loop to actually only run 5 times. And so it's not that you can't, specify things with while loops. It's just that it's a little bit more direct with for loops, and while loops have kind of some some issues with like the infinite loop. And I know I've mentioned that infinite loop thing, but it definitely is something that every programmer has run into, and it's very annoying, scary thing. And I'm sure that Karen and Stephanie can agree with me that it's kind of a pretty scary thing that we all want to avoid happening. All right, so this is a lot of information. I totally understand that, but I really wanted to sort of give you this very fundamental foundational knowledge for not just Python, but also programming. And I hope everyone was able to sort of grasp, at least some part of it. And then, we're going to now switch over to our live coding. But before we do that, I'm going to pause for some Q&A. And let me just pull that up. All right. Karen, was there any questions in the chat to address, or should I just focus on the Q&A?
Yes, I think everybody pretty much posed the question on the Q&A. So yeah, we have three. I think they're very like relevant to what you explain, and then like it helpful to help others to understand. So yeah, just the three for now. Yep.
Okay. Yeah, definitely. So I'm just going to start from the top. So how does a loop know when it's hit the last line? I'm used to using a parentheses and or a semicolon. Does this have to do with the indentation? So very good question. I'm going to go back to this for loop. So it knows when it's hit the last line. In Python, you don't actually have any semicolons at the end. That's something that you see more in Java and C++. That's not any sort of syntax that you need for Python. So the way that it knows that it's reached the end is just when when it's seen like this last line of the clause that's inside the for loop. So here we only have one line, and basically here you can say that, oh, it's reached the end because of this parentheses, but that parentheses is there because you sort of have this print statement. But basically when it's reached the last line of that clause, and when you sort of decrease your indentation and go back out and you sort of exit the for loop, that's when you know that it's reached the end of it. And so we don't really have any semicolons as syntax for Python. That's something that you see more in Java and C++. All right, so you can use a for loop to loop over a dictionary. What syntax would that follow? I don't know off the top of my head. It's not extremely common to iterate over dictionaries, although it is an iterable. But basically you would, let me see if I can find an example.
I can
you.
help a little bit here.
Okay.
I'm sorry, I'm just typing. So KB in a dictionary. So I'm typing, Lizzie, I'm typing the example for you.
Okay.
So basically, one way to loop I know to loop a dictionary is, you can actually loop it on. Because like the difference between dictionary and a list, like a regular list, is like because dictionary has index, like we mentioned, like so does the tuple, like we ran over the last section. So in order to do that, you put for K and V, K comma V in dictionary something something. So that way, so with the K index, the K is indicating the index, and the V is indicating the value in the index, in the group, like in that group of index. So so basically to call our loop, like you just have to you just have to call out both elements at once in order to loop it. Otherwise, that's the common way to do it. Feel free to try it, guys. Feel free to trip in. But that's something that's so far I've been using.
All right, thanks, Karen. And I see a question, one more in the Q&A. Can you please explain the while loop again? Yeah, so here I have sort of our slides on while loop. Let me go back. Yeah, so if you want to think of a while loop, it's something that where you're executing the code over and over again, and it'll only it'll keep executing as long as whatever condition you have associated with the while keyword, as long as that condition is true, it will keep evaluating. So as you can see here, while spam is less than 5. So here spam is less than 5 is our condition. So as long as that condition is true, then whatever code is inside this clause here, it will continue, it will execute. And then it'll basically go right back to the beginning of the while loop and then evaluate this again. If it's true, it executes this code again. And then if it's true, it goes back again. But if it's false, then it'll immediately exit the while loop and then it'll continue on to whatever code you have after that. So hopefully that helps to sort of clarify while loops. Okay, I don't see any more questions in the Q&A. So now I'm going to jump over to our notebook. So let's get into some coding. All right, so as you all know, the link that was provided to you, it takes you to this right here. This is our GitHub repository for women who code Python. It has not only the resources and materials for this session, but all other previous and ongoing sessions in this track. And so what you want to do is scroll on down and go to Beginner Python Study Group, click on that, and then it'll take you to here. And then under session materials, you want to access Colab Notebook. So for the slides, you access this. This is a Colab Notebook. So please put a thumbs up in the chat if everyone is able to access the notebook and is able to get to this, this stage. I just want to make sure. All right, I see a bunch of thumbs up, so that's great. I just want to make sure everyone is able to get to the notebook before we start coding. All right, so here's kind of a really nice sort of infographic that I found. And hopefully by the end of today's session, you'll be able to sort of revisit this and understand what exactly is going on here. And so as you can see here, we have, we're declaring an iterable here. We basically have a while loop. We have an if condition. We have an else condition. And with this sort of GIF that we see, you're able to actually see where is the code actually executing. Is it evaluating the if statement? Is it evaluating the else statement? How many times does it go back into the while loop? And how many times does the while loop actually execute until it just stops executing? So just something to keep in the back of your mind. And if we have time at the end of today's session, I'll make sure to revisit this and see if anyone has any questions, or I can kind of step through every single line of code that we have going on here. But to get into the agenda for today, so we're going to start out with an if statement and then an else statement and then an elif statement, and sort of putting all of those three together. And then we're going to go into our loops. So we have our while loop and our for loop. So here we have an if statement. So this is basically we're going to write a Python program to illustrate an if statement. So here we have I equals 10. And what we want to do from here is basically we want to check if I is greater than 15. So basically this variable I that we've already declared to be equal to 10, we want to check if it's greater than 15. So the way we do that is we're actually going to put a parentheses here and then say I greater than 15. And you want to make sure that you have a colon here. You want to make sure that this if keyword is here all in lowercase. And this I greater than 15, as you remember, is our condition. So as long as this condition is true, then whatever is inside here will get printed out. And so what you want to print out here is now we want to say something like 10 is less than 15. And the reason we print out that is because we're basically saying, okay, if I is greater than 15, then it's going to evaluate to true. But in this case, I is equal to 10. So we're actually not going to be printing out whatever is inside here, because actually 10 is less than 15, as we all know. So instead of printing out 10 is less than 15, what we're going to print out is basically say, I am not in if. So if you run this piece of code, what will evaluate, let's see. All right, so the output that we get is I am not an if. And that's true because I is equal to 10. And then our if condition here is I greater than 15. As we all know, 10 is less than 15. So basically this entire piece of code is not evaluated at all because we basically recognize that this is false. So then it jumps right to this clause, and that's why this piece of code is printed out. All right, so hopefully everyone is able to sort of understand how we're illustrating an if statement here. Next, we're going to do sort of building upon our if statement is now we're going to illustrate an if else statement. So what we have here is I equals 20. So now we have a slightly different value for I. And now the first thing we want to check if I is less than 15. And I've already put the colon in there, but that's very important because if we don't have a colon there, then it's going to give you a syntax error. And then from there, we want to print out. So if I is less than 15, then basically we're saying that I is smaller than 15, right? And that makes sense because if I is less than 15, that means that I is smaller than 15. And that's why you're actually visiting that clause that's in that if statement. And then from there, we want to basically print out another, let's just put another print statement saying, I am in if block. So basically saying that, we entered this if condition, the condition was true. Then we visited this clause, and now we're able to actually print out everything that's in this code block. So remember going back to those blocks of code. So this is essentially block 1. This is also block 1. Here we have block 2 because we're actually indenting. And then we sort of go back to block 1 in this else statement and then go back to block 2. All right, so now we finished that if statement. Now let's do our else statement. And again, we don't have to put any sort of condition with the else statement. All we need is a keyword and the colon. So here we're saying that we know I equals 20, and we've already checked the condition of I is less than 15. So why don't we say that if we're evaluating anything in here, that means that I is greater than 15, right? So let's say I is greater than 15. And then another thing we can print out is I'm not, or I'm in else block. So basically, we're saying that this I is less than 15. This was false. So then we came to our else statement, meaning that I is indeed greater than 15, because if something is not less than 15, then it has to be greater than 15. And then just basically just reassuring that we're actually in this else block. And then, so there's also a case where say that something's not true for this if or the else statement. So basically what we can print out here is I'm not in if and not in else block. So this kind of, these print statements are, not as important to not as important as what exactly you're writing in them, but just more for you to understand the sort of the reasoning that we have going on here. So as you can see, we had our value of I declared as 20. And then we're checking basically if I is less than 15. If it's not 15, then we go to our else condition, basically saying I is greater than 15. So we're in that else block. And then once we exit the else block, then we go back to our block 1. We're basically printing out that I'm not in if and I'm not in the else block. So we run that. Now we can see that I is greater than 15. I'm in else block, and then I'm not in if and not in else block. So basically, this is true because I is equal to 20. So that's why we entered this, this block here. So we print out I is greater than 15. I'm in else block. And then this last print statement is printed out either way. So whether I was less than 15 or I was greater than 15, because we're sort of getting back to that block 1. So we're sort of decreasing that indentation, basically going back to level 0, no matter what this, this line of code is printed out. All right, so now we're going to do the elif statement. So here we're basically going to have an if, elif, else ladder. So we're going to make it even more complicated. But rest assured, we are going to, I hope everyone can sort of, reinforce their understanding, and hopefully this will help for you to sort of understand how we kind of put everything together. So again, we have I equals 20. So we basically have that same variable of I, and we're setting that equal to 20. So let's say the first condition we want to check for, if I is equal to 10. So what we do, again, we have those parentheses and we say I. And remember, we have that double equal sign for equal to. If you just put one equal sign, just like here, that's how you declare a variable and how you sort of set a variable equal to some numerical value or to some, if you're declaring a string, if you're declaring a list, you sort of have a series of values. But you need this double equal sign to actually check for, whether something is equal to or not equal to. And again, that's a Boolean operator. So what do you want to check for here? If I is equal to 10. And then let's just make sure that we have that colon there. And so now we're entering our first indentation. This is basically block 2. So if I is equal to 10, then let's just say, let's print out I is 10. Okay. Now we actually have two elif conditions here, elif statements. And so basically, if this first thing, this right here, if that evaluates to false, then we go here. And obviously it is false because I equals 20. So now we go to the second sort of statement that we have here, and this is our elif condition. And so now let's check for maybe I is equal to 15. All right, make sure we have the colon there. And now we're entering again block 2. And here, let's say we want to print out I is 15, right? All right, but again, that's not true for us. I equals 20. We knew that from the beginning. So now let's try one more. Let's say I equal to 20. And so this is what is true. And so basically now the code has gone through this. It was false. Then it moved on to this and it was false. And now it's gotten here and this is indeed true. So now let's print out I is 20. All right. And then in the case that, sorry, let me just put a lowercase there. So in the case that say our I value was equal to 21, that means that all three of these would evaluate to false. So then it would get to this else statement all the way at the end. And then let's say we would print I is not present, something like that, say like our I value is just not existent here. So if you were to run this piece of code, you can see I is 20. But now let's mix it up. What if we changed I equal to 10? We should expect that first one to evaluate. So this first if statement should evaluate, and that's why we get an output of I is 10. Now let's say we have I equals 15. If we print that out, I equals 15. And now let's put something that's not 10, not 15, not 20. Let's just put 1 with a bunch of zeros. And we should expect it to say I is not present. So that hopefully clarifies kind of how we can have a little bit more of a complex series of flow control statements where you have if, you have elif, and then you end it out with an else statement. So hopefully everyone is able to sort of grasp this a little bit better. And so here we kind of have everything put all together, and this is a bit more advanced. So this is something that we've kind of already populated the code here, and I don't really want to code this live with all of you, but I would highly suggest that after today's session, before the next session, sometime that you have, revisit this and sort of walk through and understand. And we do have sort of these comments written next to every line, so you kind of know what is going on. So as you can see here, we're basically saying we have this ice cream variable, and then we have all of these if statements, a bunch, and then we have 1, 2, 3, 4, 5 elif statements, and then we have one final else statement. And all of these associated comments are here. So if ice cream equals chocolate, we're basically, you can check here, it says check if the answer is chocolate. So I'm not going to go too much more into depth on this. I just wanted to sort of point you towards this, that we do kind of have this pre-filled in code for you. And I would highly suggest that you revisit this after today's session. All right. So let's move to the loops. So we're going to have a while loop at first. So here we're going to write a Python program to illustrate while loops. So This count equals 0 is something that we have kind of seen in the slides also. We kind of had, I equals 0 or spam equals 0. So this is a very common thing that you typically start out a while loop with. Like you're basically declaring a variable and it has a value of just 0. So you're basically starting from like, 0.0. From there, we're going to now have a while keyword. And then inside here, we have our condition. So what we're going to do is we're going to go back to this variable of count, and basically we want to keep evaluating this while loop. So basically keep checking if count is less than, let's say, 3. Okay, and then make sure to have that colon right there. And then we're going to say count equals count plus 1. So this is a very common thing that you also saw in the examples from the slides. Basically, this means that every time you go through the loop, the count value is going to be increased by 1. So if evaluated once, count will go from a value of 0 to a value of 1. And then from there, let's just print out sort of a very, nice hello, fellow coder. Okay, just make sure I got that right. Okay, and then basically after that, we're going to check another condition. So actually I have that down here. So let me just remove that. All right, so I'm gonna run this now. And what we would expect is for this print statement to be printed out 3 times. So as you see here, we see hello, I spelled that wrong. Hello, fellow coder. We see that printed out 3 times. And the reason is because we start out with the count value being 0, right? And then we're basically saying the first time it goes through, count then equals count plus 1. So then this count variable is being replaced by adding 1 value to it. So basically count now equals 1. And then it's going to print out hello fellow coder. And then it goes back to the end and then it checks for the condition while count is less than 3. So as you know, count was equal to 1, right? So count is less than 3, 1 is less than 3. So let's revisit this loop. And again, the count value is going to be increased by 1. So now count is equal to 2. And then we print out hello fellow coder. So this is the second time it's being printed out. And then it goes back to the beginning. And then again, we're checking while count is less than 3. So remember, count was equal to 2, which is still less than 3, okay? And then since 2 is less than 3, we enter the while loop one more time, and then we basically add on another value to that. So now the count goes from being 2 to 3. And so then we print out hello fellow coder one more time, and that's the line that you see here. And now we go back to the beginning again, because as you know, we keep checking this condition over and over again until it's false. And so now, as you remember, count was just equal to 3. But this condition here is checking for count is less than 3. And so 3 is not less than 3. Obviously, 3 is equal to 3. So we exit this loop. That's why you basically exit the loop, and then you just return and you exit the code block. And that's why you only see hello fellow coder printed out 3 times. A very simple thing we can do is say we change this value to while count is less than 4. If we did that, can anyone put in the chat how many times we would see hello fellow coder printed out? How many times would we see that printed out? All right, I see 4. And that is correct. That's absolutely right. So we see it being printed out 4 times. And that's, that just shows you how many things you can do with the for loop. This is obviously a very simple demonstration, but yeah, it shows, what can you do with a while loop. And then after this, we'll move into a for loop, and you'll see kind of what we can use that for. So here, what I have here is now, this was kind of the traditional thing that I had already been showing to you that we had from the slides. This is slightly different. So what we're doing here is actually we're checking if the list still contains any elements. So what we do here is we say while A. All right, so when we say while A, that basically means that it's running through this this A variable. And this A variable is a list containing the values of 1, 2, 3, and 4. So while A, meaning that we keep running through the list of A, then let's say we want to take out an element from there. So what we're going to do is basically A dot pop. And I don't know if you guys remember from the previous session, dot pop my mistake here. All right, dot pop was a method to basically remove an element from the list. So basically, while we're going through while we're running through this list of A, every time we run through it, we want to remove an element. So when we run this piece of code, what you should expect is basically we're printing out 4, then 3, then 2, then 1. So we're basically printing out every element that's in A. So if you were to say just add in 5 here, then it would print out 5, 4, 3, 2, 1. And as you can see, this sort of thing can be used for lots of different cases. While loops and for loops are very powerful, and what you can do with them, they have several use cases. And yeah, so this is kind of just showing you how you can use a for loop with a list. And then here we have the continue statement and the break statement. So again, I don't want to go too much into depth on this. I introduced it very briefly in the slides. And here again, we sort of have this pre-populated code. Please revisit this after today's session and sort of look through it. I didn't want to spend too much time. I wanted to sort of move on to the for loops from here and make sure we have enough time for any questions at the end. I didn't want to have the session run over too long. So here we have an example with a continue statement, with a while loop, and then we also have an if statement sort of embedded in there. And then here we have our continue statement. As you can see, all we have to put in is that continue keyword. And then here we have a similar thing with the break statement. So again, we have that while loop with an if statement, and then that's very simple break keyword. So please go back and look at this. And if you ever do have any questions, we do have a channel on Slack devoted to this series, which can always be used to ask any questions that you have. You can also directly message any of us panelists that are on today's call, and we would love to answer anything for you and clarify any questions that you might have. All right, so the last component that we have today is our for loops. So here we have a for in loop. So as you remember, for loops, you kind of have two different ways you can write this out. So you can either use that range method, or you can have this, you can use this like in keyword. So what I've chosen for today's implementation is that second way, is like with this for in loop. So here we're writing a program to illustrate iterating over a list. So let's print out, so let's first print a list iteration, and then we're declaring our list. And this list is basically going to be called L. And inside there, we have 3 different values, women who code. And then what we want to do here is basically iterate over this list and print out every element in there. And when I say iterate, basically means to go through every single element or every single value that's in something. So what you want to do here is for I in L, and that's it for that first line of code. So as you can see here, we have our for keyword, we have our I, that basically means that it's referring to every individual element that we have, and then we have our in keyword because we're basically going inside our iterable. And in this case, that iterable is a list, and our list has already been declared here, which is L, and that has these 3 elements. And then what do you want to do? So for every single element in there, what you want to do is just print it out. So that's a very simple way to basically go through the entire list and print out everything that we have in there. So once we run that piece of code, as you can see, we have women who code. So if we were to say, let's just add on women who code Python, because that's the track that we're in right now. Now it basically will just add on another element, and now it prints out women who code Python. So this was a for in loop, and then here we're basically doing the other way of for loops, and that's basically using range. So here we have for I in range, so we basically still have the for keyword, we have I, we have the in keyword, but instead of saying just for I and L, we're actually now saying for I in range, and then inside range, we actually put in some numerical value, or you can also put in something that evaluates to a numerical value. So what we're actually going to do here is do for I in range, and then we're trying to do the same thing. We're trying to print out everything that's in this list that we have already declared, right? So what we can do is, if you remember len, which basically takes computes the length of something, so basically how many values are in there, and then let's say length of L. So now it's basically going to go for I in range length of L. So the length of L is 4, right? Because we have 10, 20, 30, 40. That's 4 values. So basically this is saying for I in range 4, but in this case, we just specified it a little bit further to be length of L. And the reason why we want to sort of get into the practice of using something like this is because, say if we were to just simply add in like a 5th value, if we had directly put in for I in range 4, then it will no longer evaluate to the entire length of the list. It's basically just going to stop at 40. So when you use things like length of L, instead of just sort of hard coding it and putting in that direct value, it makes it a lot easier down the road if you try to change values of anything, or if you try to make things more complex. So this is kind of like a nice, a good practice to have. So after we do that, now what we want to print out is basically print, and then we do L, and then in that we basically put I. And let me just see. All right. So the reason we have it like this is because if you remember, the way that we sort of index any value in a list is by using these square brackets. So now it's basically recognizing that this I that we have in here is what this I is referring to. So that I is basically any single element of this list, and basically we want to print that out. And so now we were able to print out L. So those brackets are basically indexing and just basically pulling out that element that refers to that specific index. And the index, as you remember, is sort of the position of an element in the entire list. So this 10 is basically in the 0th index, the 20 is in the 1st index, and so on. So we print that out, and then now we would expect this to print out 10, 20, 30, 40, 50, and that's correct. And now let's say if we had just done for I in range 4, that would basically print out only 10, 20, 30, 40, but that's not the entirety of our list. So that's why you want to do something like length of list and not just, hard coding it and putting in 4. All right. So we just iterated over a list, and now I'm going to do it over a tuple. And as you remember, to compare a list and a tuple is immutable. Immutable means that you cannot change any value that's already been added in there. So you can't really change whatever that tuple contains. So what we have here is a very simple, we're just printing out tuple iteration just to sort of distinguish this between our list iteration. And then here we're declaring our tuple to be the value of T. So that's our variable T. And then that has 3 values inside of it, women who code, just like we had in our list right up here. All right. And so again, we have our for loop. And what I want to do here is basically do a for in loop. So we're not really doing the way that we used range up here. We're basically just going to do for I and T. And we want to print out everything that's in that tuple. So what we can do is basically just print out I. And that is it. So if you run this piece of code, as you can see here, we have women who code, and this is our tuple iteration. And next we have a string. So I'm basically here, I'm illustrating all the different data types that we have already gone over. So I went over a list first, then we used the range function, then we just finished a tuple, and now to end with, I'm going to do a string and then a dictionary. And so there was a question about a dictionary, how you sort of iterate over that. So hopefully this will help to sort of clarify how you have for loops with the dictionaries. So here we're iterating over a string. So again, I'm just going to start out by printing string iteration. And then what we're going to do is basically declare this string variable as s and set it equal to Pythonistas. And then what you want to do is basically print out every single character that's in that string. So what we can do is basically say for I in S, because S is basically our string variable, and we basically just want to print out I. And if you run that, now you can see that every single letter or character that's in that S string is now printed out. And then lastly, we have a dictionary. So here we are iterating over a dictionary. And we basically, the same sort of thing we've been doing in the past, we basically have a dictionary iteration just to sort of distinguish this, what exactly are we doing here. Then I have set D equal to a dictionary, and then we basically have our key and value pairs. So we have our first key as XYZ, and the value that it's associated with is 1, 2, 3. Then we have our key ABC, and that associated value is in 3, 4, 5. So the similar way that we printed out for a list and a string and a tuple, all we have to do is for I in D. And then what you want to print out here is basically, there's a little bit of more complicated formatting, and I'm not really going to, I don't want to overcomplicate things, but this is basically the code that you use to print out to get it in this kind of format. So this, percentage sign S and percentage sign D are basically so that you can format it in a particular way. But what the important thing here is that we're basically printing out I, and so that I is basically our key, so that XYZ. And then along with that, we want to print out DI. So basically now it's looking at that dictionary that we've already declared, and then basically printing out the associated value. So we're basically printing out the key and then its associated value, and then we keep doing that. So if you were to say add something else, let's say DEF, and let's set that equal to 7, 8, 9, or let's do 6, 7, 8. Okay. And so now if we were to print it out, then basically now it prints out that third key value pair that we just added. So this is a very simple way that you can use a for loop with a dictionary. All right, so I believe this is our last. Okay, so we have one little last piece of code, and this is using a range. So I'm going to go over this a little bit quicker since we don't have too much time left. But here I'm showing how you can use the range method with a for loop. So I did demonstrate this earlier, but just a couple more examples. So first we have for I in range, and here say we want to specify a range of 10. I just decided that, it can be anything that you want. But then let's say we want to print I, okay? And if we just call that, basically it's going to print out 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a very simple way to basically just looking at very simple numbers. We're not declaring any sort of list or tuple or string or dictionary. All we have is that from the range for I in range 10, print out I. So basically we're starting out from the value of 0, because as you all know that we start everything from 0. And then we're basically printing it out 10 times. And so basically we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's why it's printed out up to 9, because we start out at 0. If you were to start out at 1, then we would print out up to 10. But if you were to print out, say, for I in range 20, now it's going to print out 0 all the way to 19. So basically it's like 20 minus 1 is like the highest value that you're printing out. All right, and the last example that we have here is we're going to take a little bit more advanced, and now let's say we want to take a sum of the first 10 numbers. So here we're declaring this variable sum, and we're setting it equal to 0. Then we want to say for I in range, and what we want to put in here is for I in range 1 to 10. So if you remember, this range method can take in 3 values. So here we have put in 2 values that it can possibly take. Up here, we just put in a single value. So when we have 1, 10, that basically means that it's going from 1 all the way up to 10. So that's how you can sort of specify it even further. And then that third value that you can actually put in, I'm not going to demonstrate that example here, but just in case you were wondering, the third value, say if you were to put 2, that basically means how many times you're basically jumping up. So if I were to go from 1 to 10, instead of going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, that next jump that I would take would be a value of 2. So I basically go from 1 to 3 instead of 1 to 2. But that's a little bit more complicated. I just wanted to clarify that in case anyone was wondering. So here we have for I in range from 1 to 10. And now let's just say sum is equal to sum plus 1. And then we're going to print out, okay, this is the sum of the first 10 numbers. And then I'm just going to print out sum, okay? Because what we're computing here is basically, as you saw up here when we're printing out for I in range 10, this is basically all the digits from 0 to 9, but now we want to take the sum of all of them. So basically adding 0 plus 1 plus 2 plus 3, etc. And the way we do that is by first declaring this sum variable as 0. So it basically starts out as, nothing. And then it basically is going to go through the values of 0 all the way up to 9 and basically keep adding them. And the way it does that is through this line of code right here. And then once it's done executing that for loop, it then will print out, this is the sum of the first 10 numbers, and the sum that we get, let's see, that is not, let me see. Sum is 0 for I in range. Oh wait, I think let me see here. No, okay. It should print out 45. Let me see what's going on here. Sum is 0 for I in range 1 to 10. Okay, well, I realized what happened. So when I did sum equals sum plus 1, that's basically going to be saying, okay, I'm going to start out with 0 and then I'm basically just going to add 1 to that. But what I actually wanted to do was sum equals sum plus I, because this I value is actually every value that's up here from 0 through 9. So now it should print out 45, which is basically the sum of 0 through 9. Sorry for that mistake. But that's coding. Things happen, and things don't always end up what you want them to do. But as long as you can sort of catch the mistake. And yeah, so hopefully everyone was able to sort of understand this example. It's a bit more advanced, but just to sort of show how we can have a different way of doing a for loop using this range method. And then again here, as we had for the while loops, we do have a continue statement and a break statement. This code is already pre-populated for you because we didn't want to sort of make this a huge component of the live coding section. We just wanted to sort of show you this is how you would implement a continue statement and how you would implement a break statement. And you can do that for both a while loop and a for loop. So again, please take a look at this after today's session. And now we're sort of revisiting this little piece of code. And I'm just going to take like a minute or two just to kind of explain what is going on here. So hopefully now this code makes a little bit more sense to all of you. So what's happening here is that we're declaring this list, and this list is called numbers. And this numbers list contains 12, 37, 5, 42, 8, and 3. And I'm not going to spend too much time explaining like the nuances of this code, but I just want to show you that this while loop is basically checking while the length of numbers is greater than 0. So what does that mean? That basically means that while numbers actually contains contains at least one value in it. And the reason why we check for that is because we're actually using this .pop method. And remember that .pop method helps to actually remove a value from any sort of iterable. And then this if and else condition, what these are checking for is whether the number is even or odd. And depending on whether the number is even or odd, it basically gets put into a new list. So as you can see here, let me see when it starts from the beginning. All right, so now it has this number is equal to that, then even is empty, odd is empty. And so while the length of numbers is greater than 0, as you can see here, we have 6 elements. Now we look at the first element is 3, and that's odd, so it goes into this list. Then we see that we have a number of 8 that is even, so it gets put into this list. Then the next element is 42. That is also even, so it gets put into this list. Then we have 5. 5 is an odd number, so it gets put into this list here. Then we have 37, that is also odd, so that gets put in here. And the last number that we have is 12, that is even, so that gets put into here. And so now the length is 0, so then the while loop stops executing, and then now the numbers list is completely empty, and now we have sort of our even list and our odd list. So hopefully this makes a little bit more sense than when we first saw it at the beginning of today's live coding session. And I hope everyone can sort of understand this a little bit better. And if you do have any questions, please let us know. That is the end of today's live coding session. Here are some references for you. So a lot of the material from today was taken from this really nice book, Automate the Boring Stuff with Python, specifically chapter 2. And then W3 Schools is also a really, really wonderful website. They have some instructions on some material covering if and elif, and then also some official documentation from the official Python website on flow control. All right, so that is it for the live coding. And I'm gonna go back to the slides. Let me just take a second here.
Meanwhile, I just want to answer quickly on Christian and Lacey question on Q&A. Yes, Christian, that one, the print statement, there's a 2 way to do a print function. The way putting a comma between a string and an integer, it actually work perfectly fine as well. And if you want to use plus sign, it has to be the same type of data type. And Lacey, if you have a list of number that 113, you get this number, like you can loop this over by adding comma. Yes, but like just a bit little mindful, iteration has to be done one by one. So if you want, it depends on how you want to set up the number. So if you wanted to go through the whole list like one by one, then you have to put like comma in every single one in between. And if you want you want the first one to print as 11, then you put 1 1 and then comma, and then 3 4 and then comma, and 6 6 and then comma and 7. Yes. And then Jackie, I will print Rishika, did we go over the dictionary print statement?
Yeah, let me just put that. Should I just drop that in the chat, or what would be the best way?
Maybe drop it in the chat so everyone can see it as well.
Maybe I can just yeah, I'll just put that in the chat here. So that's the specific print statement. So that doesn't include the for loop itself. This is what you would put inside the for loop. And yeah, the what you see here in front of the actual the values that are being printed out is basically the formatting that we're applying to that.
And also and then that we go quickly over. Let me see. So the one the code you just post over there, print string alliteration, the problem lies on the end, the /n, because it's not literable, because this is actually basically indicates like I'm gonna start a new line. So if you remove the first two characters in the print statement, it should work. It should work. And then if you want to literate, actually, if you want to literate, hopefully it helps. I'm not sure that was the issue. Let me know. We can talk over on Slack as well. So I just want to do a really quick thing before we end the section. If you guys have a great job for everyone to follow, like to completely follow through, like absolutely great job. But I just want to let everyone, if you actually don't understand like as one part or the most of the part, you're completely in the majority. Trust me, it is
Definitely.
not. This is very very tricky. So let us know. We will have a review session next week. So let's go through, like, let us know in the survey. Stephanie just posted and what we should go over. For example, if you're not too comfortable with while loop or for loop, or if else, or any other any other thing, like let us know, and specifically what you want us to work on, and we can show your example. Remember, you mentioned it, you're not alone there. If you don't understand, that means like someone else there actually don't understand the same question. So please let us know, and you really have to just let us know. And then like we all learning here together. Me, Rishika, and Steph is we will learn with us, we will learn with you guys. So yeah, feel free to let us know, and then the review, and then like we can go over the review week. Rishika, I'm gonna pass it back to you, sorry.
Yeah. Thanks, Kim, for mentioning that. Yeah, definitely. I see myself as like still always learning, and I definitely agree that there's always more to learn out there, and I'm definitely no expert at all. And
Me too.
all three, Karen, Stephanie, and I are all here to sort of support you guys and ask, answer any questions that you might have. And so that's what the next session is going to be, is completely for you guys. So if you have any sort of questions, it's going to be a review session. So everything from session 1 up to today's session. So please fill out that Google form, because if you have any particular concepts that are a little bit harder for you to understand, we can definitely go over that. We can, prepare slides. We'll have slides and some, live coding for it. And it's completely devoted to sort of help you guys out. And if you have any questions, we are here to help you out with that.
Yes.
Yeah, so again, that Google form is in the chat. So please fill that out if you do have any questions. And so just to wrap up today, as I mentioned, we went over flow control statements. So we went over, the different components of a flow control statement. Then we went into if, elif, and else, and we went over for loops and while loops. So definitely, if you have any questions about it, feel free to mention that in the Google form, and we'll make sure to include anything that's in that Google form in the next session. So if anyone has any last minute questions, please drop them here. Otherwise, we are pretty close to the end of today's session. Please join our Slack channel. This is a channel specifically if you are already part of our Slack community. If not, please do join that. I believe that's also in the chat. And thank you, everyone. And thank you for remaining engaged and for answering all the different questions. And I see a question about if we have any more sessions. Yes, we do. So our next session is going to be in 2 weeks from today. It's going to be our Q&A and review session. And yeah, hopefully we'll see all of you next time. And thank you, everyone, for joining. I hope you have a wonderful rest of your day, evening, morning, wherever you are joining in from the world. And yeah, thank you, everyone.